Aquaculture is the only solution for bridging the gap between declining ocean fisheries and the increasing global demand for seafood. However, much of the aquaculture industry is dependent on marine raw materials such as fish meal and fish oil, which are from those fisheries and therefore a limited resource. To use raw materials in the best way, it is important that we fully understand the secrets of fish nutrition and how feed raw materials can be used to greatest effect. For many years, the Skretting Aquaculture Research Centre has conducted research to understand and find solutions to these challenges. This is the story of the microbalance concept and how the secrets of this feed science were uncovered. Traditionally, feeds for farmed fish have had a high level of fish meal and fish oil. Scientific efforts to replace these with alternative raw materials were initiated in the 1990s. The first breakthrough came when Skretting revealed the need for a balance of essential amino acids. Adding extra amounts of the limiting amino acids made it possible to reduce the fish meal level in salmon feed to 25%. That seemed to be the minimum threshold when using only vegetable protein sources as alternative raw materials. Could the level of fish meal be reduced further, while maintaining the same growth rate for the salmon? The researchers began looking into micronutrition and its role in the physiological processes of fish.
The research behind MicroBalance was all about piecing together information on what happens to the fish when fish meal levels are reduced. This line of research led us to an understanding of some physiological processes that were impaired with low fish meal feeds and gave us a hypothesis to work towards. From there, it was a matter of identifying some functional microingredients that could be included into controlled experiments where we analysed their effects on growth, health, quality, and metabolic indicators. The first positive results we received were really encouraging. However, it wasn't until we'd refined the doses required and achieved good repetition of the results when we were really enthusiastic about the microbalance concept.
Let's take a closer look inside the fish to see how microbalance works. A low fish meal diet without microbalance causes the pyloric intestinal tissue to enlarge. Microbalance science ensures normal development of the pyloric intestine even with a low fish meal diet. Some plant raw materials are known to influence the intestinal structure. Microbalance has been developed to give the gut maximum strength and to optimize digestion processes. By using advanced DNA technologies, the researchers at Skretting could see no difference in the bacterial population of the gut at different fish meal levels. Fish fed a diet with microbalance contain a balanced microflora with all the good bacteria known to have positive effects. The liver is responsible for many processes in the body. Much testing on many different health indicators has been carried out to ensure that the liver function is optimized with microbalance. The skeleton is the frame upon which growth occurs. It consists predominantly of minerals, so the correct levels and optimal ratios of different minerals in feed with microbalance are critical for growth and final product quality. With microbalance, the levels of key feed raw materials can be reduced while keeping fish growth, health, and flesh quality maintained at high levels. As we explore this concept further, microbalance will open the way to reducing our dependence on individual feed raw materials, giving greater freedom to feed formulators to produce efficient and economic feeds, and allowing aquaculture to expand sustainably.